So welcome everybody, and good to be here at the Spark Summit. I remember the first Spark Summit was in a tiny little hotel at the other end of Union Square. It was kind of interesting. It was crowded in there. This is pretty amazing having this crowd. So I'm Mike Pitaro, also just commonly known as Mike. I work for BigDL EMC, and Radhika here is from Intel, and we've been working together with a library called BigDL, and we thought today it'd be nice to talk a little bit about some of the new developments in that area, specifically around the analytic zoo. I'm going to start off. I feel weird because when I wrote these slides, I didn't know what was in the keynotes, and it turns out a lot of this material here turns out to totally overlap with the keynotes. But one of the things I'm working on is kind of production AI systems, the scale and what it takes to build a very, very large AI system. And we're showing here kind of a staircase of the various steps you're going to go through in that process, but in fact, when you get into it, you find out not only do you do this, but you do it over and over again. It's like a stair climber. You keep going because you're always iterating. But from going from just the basic premise of what sort of business problem you're trying to solve, going through the initial hypothesis, is this even close? Do we have the data we need to do it? Going all the way through the data prep, the modeling, the deployment, getting things into production, and then iterating again and continuously evaluating. This is quite a lot here. I'm not going to read this slide. There's too much here. I think the key thing is there's a lot involved in going through all these steps. When you get into practice and you look at what it takes to do deep learning, you're going through multiple stages here. So you're going, even if you just focus on the machine learning part and you forget the supporting data infrastructure, even if the data was there, you still have to go through. You have to get it in there. You have to look at it. You have to start augmenting it. You have to label it. In a lot of cases, you will need humans in the loop to go through and label that data. And initially, you need domain experts that can help you test those models. You play around with topologies, and I saw a quote here. I can't remember who it was, but there was a quote about a week ago that these days everybody's using the state-of-the-art models, so you spend all your time tuning hyperparameters. That's the only way you could differentiate. But you do spend a lot of time just fiddling with the models. I'm an engineer. We don't call it tuning. We're fiddling with it. We're trying to optimize it. We're going through, and after doing all of this, you then have to roll that into production. What we're finding in practice is when you look at the whole AI problem and the full end-to-end solution, the time to actually build the environment and actually get a working solution totally dominates the time you spend fiddling with the models or actually training the system. Yes, it's significant, but in the big scheme of a project, it's only a small part of the entire pipeline. The other thing that starts to become clear as you go through these AI systems, and I think this was covered this morning in multiple keynotes, when you look at the big picture, there's a whole bunch here. It's not just a model. You know, when you work with data scientists and you work with engineers, we spend all day talking about models and libraries and frameworks. They're a small part of the infrastructure. The supporting infrastructure is a lot bigger than the code. You have configuration, you have your data collection, you have your resource management and production. You're probably going to have a separate serving infrastructure. APIs to call the models, maybe some web serving, maybe some NoSQL databases to serve up results. It gets messy. Here's the interesting thing. This isn't the prettiest slide, but if you look at this problem, you are probably already using Spark in large parts of this infrastructure. I'm going to assume, I'll do a vote here, but I'm kind of assuming that if you're doing any data collection, you're doing any data verification modeling, you're probably already using Spark there. Would that be a fair assumption in this group? Is everybody using Spark there, or are you just getting started? I know we had a lot of new Spark people at this summit, but generally what you'll find is most of that stuff, even if it's running under Hadoop, is running as Spark jobs under Hadoop. And this is pretty typical of what I see with our customers. So there's a lot of Spark here. And really, what it means is you're probably using Spark for data prep, for classic ETL, for data cleansing, probably for machine learning. At the tail end of 2016, there was a new library released called BigDL. And BigDL is a high-performance deep learning library that bolts into Spark. It actually integrates quite nicely into the machine learning pipelines. And if you look at that picture, you can see when we re-engineered Spark, when we added machine learning pipelines and the data frame concept, there were hooks put into Spark to make it fairly easy to add some new components, because in the beginning it was just Spark SQL, Spark Streaming, MLlib. Now we have MLlib, now we have GraphX. BigDL was added. It's not an official Spark project. It's independently run by a community sponsored by Intel, and Intel employs a lot of the developers, but it plugs into that ML pipeline. And in fact, we're up against another session in another room here talking about a library called Spark NLP, which uses that same interface to add natural language processing. If I wasn't presenting, I'd be in that session. But this is an interesting concept, because now you can take a look at Spark as your core kind of data processing framework, and you're actually in a position where you can use it end-to-end and add the actual deep learning in addition to the machine learning capabilities. So that's really nice. Technically, it's roughly at feature parity with Caffe, Torch, TensorFlow. There's some nitpicking details that are different in the frameworks, but fundamentally, it's a full-featured framework. It's been around for over a year now, so it's been growing in adoption. And one of the nice things about it is it uses, if you were in the keynotes, there was a lot of talk this morning about the MPI and some of the interchange. When you run deep learning and you have communications between tasks, that can get very expensive in terms of time and network. BigDL does a lot of work behind the scenes to implement those parallel algorithms so that it can run underneath Spark and underneath the Spark scheduler and not get in the way. Databricks were actually very involved in the original design, kind of giving everybody advice on how to do this underneath Spark. Inside BigDL, as I said, it's very full-featured. So you've got a bunch of pieces in here. You have all the deep learning building blocks you'd expect. You have layers, you have optimizers, you have criteria, you have predefined models in there. In terms of language support, it's implemented in Scala, but you have Python, you have Scala and Python support. You have all the integration with the Spark ML pipelines. It works with Jupyter. Cool feature, it works with TensorBoard, which I think is neat. I always thought TensorBoard was tied to TensorFlow till I started playing with this. And there's a lot of model interchange here. Something I'm bumping into a lot with our customers that implement this, either BigDL or other machine learning frameworks, they need to deal with model exchange. There's no standard, but people very often want to develop. They've either started developing in TensorFlow or they've been using Caffe. They want to pick up a model and they want to import it into another system, whether it's trained or not trained. We're seeing a lot of that kind of train in one environment, run the model in another, or just to simplify portability. So there's a lot of model interchange capabilities inside BigDL. So it's an interesting library. But that's not the problem I'm dealing with when I deal with our customers. The big problem I'm dealing with is not just the library. It's when you look at the larger scale environment, one of the problems we're having is how do you build this end-to-end kind of machine learning or AI environment? And the scope there just really challenges a lot of people. We heard keynotes this morning from companies that are doing this. Well, you know, they've kind of committed to it, and they said, we're going to go through and do this end-to-end. But a lot of the folks I work with, they're kind of getting into this. They may not be on the bleeding edge. Some of them are, and they're well ahead of us. But a lot of them, they're just trying to understand how to simplify. And one of the nice things about it, when you look at open source frameworks, you've got Spark as your main framework. As I said, a lot of our customers run Hadoop as their platform and Spark underneath it. But it's really nice to have these open source components where you can kind of look at them, you can track them, it's very transparent. You can see how fast the industry is moving. There aren't that many commercial companies doing this stuff. If you look at any commercial company that's selling software, it's open source underneath. I'm not aware of any proprietary deep learning libraries that work with Spark. They may be out there, so don't quote me on that. But the big problem we have is just getting this stuff scaled up. Both the data prep, the runtime environment, all of that ends up being a problem. The other thing we're bumping into is, you know, if you have an existing platform like Hadoop, running BigDL to me makes sense because you already have a cluster. You already have processors. You already have memory. We talked a little bit this morning. I wasn't paying attention to keynotes, but there was another keynote where we talked about having the two clusters. There's the training cluster. There's a runtime cluster. It looks great on a whiteboard. The trouble is you have the data movement. I'm working with folks that already have the data and already have large clusters, and I mean large clusters. It makes sense to do most of their computation and most of their deep learning on the same cluster. So this is the nice feature. As you look at what's happened with BigDL over, I want to say the past year, year and a half, we've seen a lot of the workloads picking up. You know, it's being used in production in consumer, in healthcare, in finance, and retail, especially in kind of my niche, scientific computing. You know, it's being used across the board, so people have adopted it. In terms of technologies, there are multiple vendors. We're not the only vendor working with this, so there are multiple vendors using this technology and embedding it in products. It's available on a lot of the cloud service providers, and there are some really interesting actual case studies around specific users that have used BigDL to do interesting things. So this is the good news. It's caught on. There's just one problem, and again, I'm honest, when we worked on these slides together, we didn't know this stuff was going to be in the keynotes this morning, so I feel like I'm saying the same thing again. But what we found, even if you have an interesting framework and an interesting library, it takes a lot more. So whether you're working with Tensorflow or Caffe or whatever, we're just at the beginning of this industry. And the problem we're finding is the actual framework or library kind of doesn't matter. Where you really run into the problem and where you really start figuring the challenges is kind of switching over and saying, okay, you gave me a framework, what about examples? You know, how do I actually use this? A common story I hear from customers, yeah, we know we need to build an AI environment. How do we actually go about building it? So really what we wanted to do today is talk a little bit about, you know, as we switch over here and we talk about frameworks, if this is just the beginning, how do you actually use these frameworks? And that's where I'm going to hand over here to Radhika, and she's going to talk about a really interesting project called the Model Zoo for BigDL. And the clicker actually works here.
All right. Can you hear me? Thank you, Mike. By the way, I'm Radhika Rangarajan. I'm from Intel, and I'm from the team that actually created BigDL. And it's always gratifying to see someone actually using BigDL talk about it, as opposed to any one of us who are part of the team discussing the features. And Mike actually kind of alluded to, hey, there's so many frameworks out there. It's like an ocean out there. So what is it? Why is still AI barely limping? And if you think about AI on Spark initiatives, I mean, honestly, there's more than BigDL. There's Caffe on Spark that started. There was Tensorflow on Spark. There's deep learning pipelines. I think many of you even heard about Project Oxygen, perhaps. So plenty of efforts. Still, AI on Spark is at its infancy. And when we talk with customers, when we talk to community members, these are the recurring themes. All right, great frameworks, but I'm struggling. Where is the API documentation? Can I have some easy-to-use models? Can I have some reference use cases? And honestly, I think in the space of AI, we've come so far ahead from research. If I compare research to what happens in production, it's as different as what's novelty versus what's useful. It's not about a state-of-the-art model. It's not about squeezing in that extra 1% accuracy, but it's about building an end-to-end robust system where you have to take into considerations all the headache with your data prep. And seriously, where are those examples? Mike showed all those examples on BigDL, but wouldn't it be awesome if those examples were available as reference use cases? So if you actually had a problem you're solving in the same domain, and you're comfortable using the categories in that data set, and you want to just start off with that, as opposed to starting from scratch. So we know what to do, but how do we go about doing this? And you said this was working? Okay, yes. That's where the zoo stack comes in play. I'm assuming everyone knows about the TensorFlow model zoo? Yay, no? All right. Pretty much every framework out there, popular framework out there, has a model zoo today. But what's unique about the analytic zoo stack, which is sort of a BigDL model zoo, is it combines the goodness of what's out there with TensorFlow model zoo with the Keras goodness of Keras. And I'll talk about that. I mean, obviously, at the runtime, you know it's Spark, BigDL, Python, and it has HighLevel Pipeline APIs, so you can actually make it interact seamlessly and provide native integration with data frames and Spark ML pipelines. We also have operators for feature engineering and transformations, and built-in algorithms and models, as well as reference use cases. By the way, some of these that are captured in here are still work in progress. This is almost an evolution of BigDL. The intent of this is obviously to make it super easy to build end-to-end deep learning applications as well as AI, end-to-end pipelines and AI applications on Apache Spark. We'll dig a little deeper into each of these. This does take a little more time here. Okay. All right, high-level pipeline. So I'm going to talk about these three areas: high-level pipeline APIs, deep learning models, and the reference use cases. So pipeline APIs, you want to think about three things: NFrames, AutoGrad, and transfer learning. So NFrames is basically a package, comprises of actually 5 main APIs. There's actually a little more to it, but at a high level, it has a NN estimator, it has a NN model, it has an NN classifier model, and an NN image reader. And I'll show some code snippets on what each of these are. But the intent of NFrames package is to provide data frame-based API and native integration with Spark ML pipelines. Now, AutoGrad, obviously, as indicated here, it's for providing auto differentiation math operations. So you can create custom layers or custom loss functions. And we didn't know until 6 months ago that this was actually a need. By the way, BigDL has about 200, maybe even 300 plus layers at this point. But then every so often in the last couple of months, we've seen a customer come in and say, what if I actually wanted to create a custom layer? And if I want to do custom loss function, how do I go about doing that? So we have some cool APIs for doing that. Transfer learning, and this is obviously the most popular aspect. So we have something called Net API in the Zoo stack that allows you to actually take existing models, a Caffe model, Tensorflow model, or a Torch model, and actually load it in BigDL, and you can continue to use it for large-scale feature extraction and fine-tuning. And we'll go through a few examples in that space. Off-the-shelf inferencing. Let's say you are interested in doing off-the-shelf inferencing with some built-in models and for some of these commonly used workloads, object detection. So we have about 2 models at this point, a single-shot multi-box detector model, SSD model, as well as a fast RCNN model, both of which are actually trained on the Pascal and the Cocoa data set. So if you want to actually use those off the shelf and you want to actually continue to leverage it, if you're comfortable with those categories in the data set, go for it. You can obviously actually, when we talk about transfer learning, I'll show how you can do that. You can actually chop off a few layers, and then you can actually add a few new layers and create your own custom model as well. Image classification, MXNet, VGG, Inception V1, MobileNet, SqueezeNet, and DenseNet. We have those available, those models available. For text classification, currently we are supporting a few encoders. I think the encoders we support are CNN, LSTM, and GRU. And for recommendation ones, we have 2 models right now, which is the wide and deep model, the WAD model, as well as the neural collaborative filtering model. Okay, these are all great models, but how do you actually put them in perspective and build those end-to-end pipelines and show them as use cases? These are those lighthouse solutions. So we've actually taken these models based on our experience working with customers, and obviously we can't use a customer data set when we are putting it out there as an open source project. Based on publicly available data sets, we've created those reference use cases for anomaly detection, sentiment analysis, fraud detection, image augmentation, and so on. So if you go to the Analytics Zoo stack, you can actually go and get these examples today. Okay, so I said we'll dig a little deeper into, well, let me show this here. Into the NFrames package. I mentioned NFrames package comprises of those 5 main APIs because it allows you to actually it allows you to have a data frame-like API and be able to integrate with Spark ML. So this is an example. Obviously, you actually instantiate an NN context, and then you actually load the images into data frames using an NN image reader. Later in one of those examples, I'll talk about how you actually go about doing an NN classifier. You can obviously process the loaded data using data frame transformations, and this should be pretty familiar code. So one of the things that Mike mentioned earlier is BigDL has both Scala and Python interface. Obviously, NFrames supports both of them on Spark 1.6 as well as 2.x. What else can you do with NFrames package? Well, obviously, we talked about feature engineering transformations. If you want to do image. And these are common things that you would go about doing if you're actually doing an image recognition problem. Image resizing, channel normalizing, and so on. More interesting part is we talked about transfer learning, and I mentioned we have a Net API that allows you to load existing pre-trained models. These may be models that are available in the Analytics Zoo stack, or it could be any of the TensorFlow models. It's like, bring your own device, kind of bring your own model sort of a thing. Bring your own model or take advantage of the models that are already in here. This is pretty straightforward, as you can see. You actually load the model. Now, You can do off-the-shelf inferencing right away. You're comfortable with those categories. But if you want to actually freeze a few layers, you want to actually remove a few layers, this is how you go about doing this. Now, in this example, obviously, we are removing the layers after pool 5, but then we want to retain the goodness until that point. So you actually freeze the layers from the input until the pool 4 layer. And what do you do next? You want to actually add more functionality to it. You actually add a few new layers. Now, some of these code snippets I'm showing are based off real-world examples that our customers have actually built. So we see these as actually applicable use cases. Obviously, here we're using Keras style API, and this is where I said the Zoo stack actually combines the goodness of Tensorflow models and the Keras goodness in it, and a custom Lambda layer. There's a little more code I want to show, but I want to leave some time for questions as well. I mentioned earlier that NFrames also allows you to have a native integration with Spark ML pipelines. NN classifier and NN model can allow you to do that. You can think of them as a parallel to Spark, transformer, and estimator. So obviously, when you actually do a class fit here, the output is an NN model in this case, which is like a Spark ML transformer. Okay, so I got the 5-minute warning here. So let's go through a little more stuff here. So object detection API. I'm just going to go through this one particular use case. And I mentioned this. So we have 2 models, SSD model at this point with object detection as well as a fast RCNN model. You can download these models from the Analytics Zoo. These models obviously have been trained on just these 2 data sets. So, but it's, as you can see from an API perspective, it's pretty straightforward. You kind of instantiate the NN context, and then you actually load the model once you give the model path, and then you can do off-the-shelf inferencing and visualization as well. So that's kind of a cool thing. Okay, that was a quick, rapid overview on what's in the zoo, but there's more. Based on what we put out in the zoo and what we've heard from initial customers as well as the community members, they're saying, hey, you know what? When you're thinking about pipelines, you might want to think about actually the serving pipelines as well. So these are some of the requests we're getting. And I mentioned 3D imaging, and this is based on the work we have done in the medical imaging space. They want to have more future engineering operators for 3D imaging and text analysis. There's a built-in deep learning models need for sequence-to-sequence and GANs. There is some work, experimental work that we've been doing with reinforcement learning. And actually, we have a session using BigDL and Analytics Zoo on reinforcement learnings, and I'll share information on that. You should definitely check that out. Actually, all the BigDL sessions that are happening today and tomorrow at the summit leverage the Zoo stack. And those are some interesting use cases. So I'm hoping Zoo calls is an open source project, so definitely learn, explore, and engage and participate. We'd like to know how can we actually accelerate AI on Spark. We don't, have more reference use cases, have more models. Like I said, bring your own model, and let's see how we can make it work with a Zoo, and then how we can make it publicly available. Now, these are the interesting sessions. Now, I'm more interested in the first. Actually, I'm interested in all of them because this is from my team, by the way. But the World Bank one, it's extremely exciting because it was down-the-wire implementation for us just over the weekend, and we trained the model from scratch, and the accuracy we got, because we were training this over 1 million data set. And when we actually applied transfer learning, we went from a 25% accuracy to an 82% accuracy over the weekend. So we were like, okay, all right, so this is just transfer learning thing, and the way we actually went about doing the fine tuning is actually working. So there's more on this from my colleague, so do check that out. Obviously, reinforcement learning, that's new and experimental. Definitely check out Yuhao's session. And MLS listings has been using BigDL for a while, and they actually have a very interesting pipeline that I think many of us can associate with, because it's like going to Zillow, or when you go buy a house, look for things, look for images. How do you actually use image-based similarity search as opposed to just keyword search? And MLS Listing is going to talk about their use case as well. So there's more on Spark and BigDL, but these are more use case friendly. So do check them out. I believe I've already overused my time. So we have a couple minutes for questions. 2 minutes for questions. Oh, that's not bad. So there we are. If you're shy of asking questions, you can always find us later.
We have one question.
Hi, Radhika. Great presentation. So in terms of model import into In terms of model import into ZooStack, is there any support for Onyx yet, or is that something that is still
It's
in
in
the
our
pipeline?
roadmap, and we've heard about it, yes.
Okay.
So it's
that would
coming.
be great to see, actually.
Absolutely, it's yes.
All right, thanks.
All right. Well, I guess then that's a wrap. Thank you.